With improvements, getting the emissions rates to be considered there's different ratings on what kind of source generator you are for different waste pollutants. And just comparing to coal isn't good enough, because coal is kind of considered the nasty environmental fuel element. And basically, the air quality status, whether it's an ozone non-attainment area where the facility would be located, is very key. You cannot get a permit to emit certain pollutants in certain areas of the country, or at least the environmental regulatory people will make you wish you had tried. So investigating the status of the projected location of the facility is key.
I got a question. You mentioned nitrogen oxide. Is that something that you based on literature values, or did you use a calculation for it?
Yeah, based on the composition of nitrogen and the percent composition of nitrogen and oxygen coming out of the air gasifier.
Was that based on equilibrium or kinetics?
Equilibrium.
Okay, so you may well only get a tiny fraction of what you. Okay, thank you.
You guys compared everything to coal, and I think that's okay, because a lot of people want to know how things compare with coal. The other thing I would compare it to is natural gas, because that's the other end of the spectrum, because everybody here is, is as clean as natural gas. So I get that question a lot about our plan is, how does it compare to coal, how does it compare to natural gas? So put those two endpoints in there, show where your system is. I think that would be good. Can we go back some slides? You guys outran me. I couldn't keep up. Let's see, was that the slide? Define negligible there. I mean, we're looking at building another one of these units in LA County and Southern California, and it don't get no worse than that as far as trying to permit a plant. Okay. So I'm really interested in your third design here on the steam gasifier. I've never even heard of that or seen that or anything. So I'm really interested in that option, since the NOx is so low, because that's going to be the limiting factor in LA County on emissions is NOx emissions. So can you explain a little more detail about how it works? I know you had a graphic, if you want to go back to that.
Are you talking about the gasification and cyclone separator portion, or are you talking about the turbine?
Well,
These are where the water shift.
yeah, inside the gasifier, you had another graphic up there. Go back further. Maybe I'm misunderstanding what you're talking about. The steam gasifier, right there. Tell me how that works. What part does the steam play? There's no air going in, is that right? Chemically, what happens in there?
Instead of oxygen or the air, the steam goes to the gasifier with the post-consumer carpet.
Okay, so that instead of having air going in, it's steam. So you've got H2O, right?
Mm-hmm.
Okay. I'm not a chem E, okay? I'm a double E, so be gentle with me. So you got H2O going in there with the SynGas, right? And somehow the H2O breaks apart, and the oxygen. Explain that to me. That's what I don't understand.
You mean the reaction?
Yeah.
There are actually several reactions that take place with the gasification using steam. There's a reaction to produce methane, and then one to produce the actual CO and hydrogen.
For each of the different components.
Okay.
So Whereas in the oxygen gasifier, you just have O2. Well, here you do have oxygen and some hydrogen, but the oxygen is the key in as far as producing the SynGas from the reactions. We didn't go into detail about the reactions, maybe we should have. Maybe that's something we need to.
But it's kind of, at a real high level, it's something I'd kind of like to see.
Right.
It will be in greater detail in our report.
Yeah, okay. Because like I say, if it's that low in NOx output, it might be worth considering. The other thing you gotta know is how much steam and all that, does it, make sense? If I have to put in 3 times more steam than I'm gonna get out, it's probably not gonna work.
We designed the steam gasifier, I think it was, with the intent to actually produce electricity, which is one of the requirements, I believe, in California. Was to produce what, 5,000 kilowatt hours?
Kilowatts.
Okay. That's good.
So a lot of the steam would be used to produce electricity in a steam turbine.
There was another chart in there, I remember, go forward just a little bit. Let's see, I think the one behind that, or in front of that one, right there. So you get less, am I reading this right, you get less energy out in the steam gasifier? Is that because you're taking steam from the output and using it in the input, or? Asking a stupid question, I don't know.
The energy balance on the steam gasifier, when you're seeing BTU per pound post-consumer carpet waste, is it that low because of the energy that was used to make the steam going into the gasifier in the first place?
Yes, yeah, to heat the steam up, starting up from water, to heat that up, so that was subtracted from the initial, otherwise they're fairly close, and then you have to subtract that initial heating value.
Okay.
So if you had some kind of solar boiler or something that could get your steam, you might get a plus off of that. Especially if you're in some place where it never rained, like LA County.
It's definitely something to consider.
Where does the heat come from to run your steam methane case? I don't see any source of heat. Everything there absorbs heat. And also on making the methane, that sounds like a reaction that we all would love to see, but I wonder if it's actually can be carried out in practice. Is this based on equilibrium or kinetic considerations? So based on equilibrium, you might only get a tiny fraction of what you would get from assuming everything goes the way you'd like it to go.
All of our calculations were done based on the assumption that all the reactions will be carried out to completion.
That's something, if you're going to present it to the companies, you might want to make some review of the literature and see what actual conversions are obtained. It'd be wonderful if this happens, but it's offhand rather doubtful.
You have to take that into account in your economic evaluation anyway. Or at least you should.
Did you come across any gasifiers that you thought would be great for this operation? Or have you got that far?
That's what we're working on now. As part of the economic analysis, it's kind of hard to get a hold of people sometimes because different area codes, etc. But that's what we're working on as far as the economic analysis. We're trying to get real world prices for our units, like actual quotes, but we don't know where that's going to end up yet. But it'll be in the final report for sure.
Thank you.
Tell me a little bit about your exhaust coming off of your process diagrams. You've got a few that are showing exhaust streams. What's in your exhaust?
The products of combustion, yeah, CO2 mainly.
Do you have a sense of proportion of CO2? Is it pretty high CO2 and nothing else, or are there other components? Do you know proportions?
CO2 and water, I don't know the proportions off the top of my head though.
CO2 and water would be implying complete combustion.
Which would be after, at the gas turbine, it would, well, assuming a complete combustion.
Now, you guys had a spot in your, you guys are doing some analysis on the gasification process. And you guys had the calcium oxide as one of your, part of your ash stream. Did your BTU values compensate for the breakdown of limestone?
Yes.
Did it?
One thing that you might consider is for your conversions there, what your BTUs that you're generating, you might put that in terms of how much that could offset energy for a plant. If you're gonna put that energy back into a plant, it might be helpful for me to understand, it might be helpful for others to see just how much is the offset of the energy consumption for the plant. Is it, 2%, is it 20%, and I would, that's gonna vary, of course, by the type of plant it is and how much its energy consumption is. But if you gave some examples, that might be helpful. That just gives a person some perspective.
It's actually going to be one of the main focuses for the economic analysis, which will be in the final report. So we knew that if we're able to put energy back into the plant, then there's a definite cost savings or energy savings versus having to purchase it offsite.
Go back to one of the emissions charges, just a suggestion. Yeah, that. Well, maybe you did.
You're saying that your pollutant load is going to be 113% of what equivalent amount of coal you do?
Actually, I believe I got those signs wrong, so it'd actually be 13% less emissions, and then the 14 would be 14% more, 14% higher. I got my signs wrong.
That makes more sense,
Yeah.
Yeah, because so it's not what we see in reality, so.
So the steam is 48% less?
Yes.
Yeah, I'd like to see you put in a real number instead of the negligibles. Because if I go to the guys in Southern California, they don't buy that, so they won't see a number.
Well, when you said negligible, did you mean compared to like an EPA regulation or something?
Compared to with the air, compared to the emissions with the air gasifier, so it was so minuscule, it wouldn't come into play for our comparisons.
A number still would give someone some perspective.
People care about those things sometimes even require pavilions, so you have to tell them something.
Anyone else?
Excuse me, actually, I'm figuring your methane yield and this other issue with you assumed, excuse me, you actually assumed complete conversion the way you wanted it to go, right? So it's not equilibrium and it's not taking into consideration kinetic the actual reaction kinetics that would go on. So, am I right in that? You're just assuming that the reactions take place just the way you want them and they go full completion?
Yeah, for this analysis, that's how we do it.
Yeah. It makes life simple, but.
It does, we understand, but
Yeah. Okay,
Well,
thank you.
from the standpoint of estimating pollutants, if you're going to do a calculation that gives you the theoretical maximum that you could possibly get, that's pretty good. Because basically, if everything that's there, it could possibly turn into a nasty pollutant does, and you're still okay, at least in theory, it's gonna look pretty good. But you, get a handle on economics, getting a concept of the percent completion you can expect is very critical.
Yeah, for CO2, that's entirely reasonable. Carbon does come out as CO2, very large percentage. For nitrogen, it's a different animal.
And for methane, it'd be a different animal.
For methane, yeah.
As you're presenting, it might also be good to show more of your equations, your equilibrium equations, your conversion equations. And then, kind of as you're going through your presentation and you're talking about those things, just kind of explaining that these are theoretical explanations and that they don't occur really in reality, that the proportions are different in reality in practice, but just kind of getting that out there is really helpful for an audience to understand, this isn't the perfect world, and we know the world's not perfect, so it doesn't happen exactly like this, but this is the way the chemistry works generally, so that's sometimes helpful for an audience.
What temperature does each of the gasifiers run at in the gasification chamber vessel?
Off the top of my head, we should have put it in here, but from what I remember, it's something around 1700 for the air and O2, and I feel like it's lower for the steam. I don't know the specific numbers right off the top of my head. I mean,
Something I'd like to see is what temperature does it operate at?
Okay.
And that would be good to put on your process diagrams. You could add that in your graphics there pretty easily. That would be a good piece of information.
I think it would have helped me if you had sort of a process flow diagram of your boiler and your gasifier showing the loop to, of maybe natural gas in the boiler, BTUs in, BTUs out, and a recycle loop of BTUs based off that SynGas that comes back to your boiler. Just almost just an energy balance right there, but in a drawing form. It would help to explain to everyone a little bit